Hey everybody, welcome to the 8.1 video for the notes. This one's going to go through a few properties. I'm not going to do any examples in this video. There is a separate video for examples. So if you want to see some examples, go to that one. This one's just going to give you the straight information on the theorems themselves. So if you're looking for that, this is where you want to go for that information. So let's start out with the polygon interior angles theorem. What this says is that if you want to find out the angles, all the angles, the sum of the interior angles, sum of interior angles of a polygon is just a multi-sided shape with a few properties to it, which we'll get into soon. But if you want to find out what all the total of the angles inside of them are, and it could be any polygon, you just use the formula n minus 2 times 360. I'm sorry, times not 360. I'm jumping ahead a bit. Times 180. There we go. So, for example, if we had any six-sided shape, it doesn't even have to be equal sides, 1, 2, 3, 4, 5, 6, okay? I purposefully didn't draw those equal. There is a six-sided shape. If we wanted to know what this plus this plus this plus this plus this plus this was, what we would do is we would then plug 6 in. N is the number of sides in the shape, so since this is a hexagon with 6 sides, we're going to do 6 minus 2 times 180, and that would give us 4 times 180, which ends up being 720 degrees. So that would be those angles all added together. And that's how that property works. A little corollary to that, a little extra thing that we should be aware of is we're going to be dealing mostly with quadrilaterals in this section. So a quadrilateral is a polygon that has 4 sides. You have quad in there, and quad is it's a prefix that means 4. So 4-sided shapes. Using the formula above, if we plug 4 in for the number of sides, we're going to see that we get 2 times 180, which is 360 degrees. The angles in a quadrilateral always add up to 360 degrees, and that's going to be quite useful for us at various times throughout this chapter. Okay, so a few things also to remember about polygons that will come into play in the near future are the definition of a regular polygon. Regular just means that all sides and angles are congruent. So quadrilateral-wise, this is not the only shape that, well, actually, for quadrilaterals, it really is the only one that works this way. Your squares are regular shapes because their angles are all 90 degrees, and the sides are all congruent. That's what makes it a square. So those are regular shapes. Equilateral triangles are also. Convex polygon versus concave polygon. Convex means that all of the angles are kind of jutting out. So we have things like this, where all of the angles are kind of pointing outward. Concave is not like that. Basically, concave could be something like this, where some of the angles are jutting out, but you have an angle or two or more that are going inward. Most of the things that we're going to be talking about are going to be convex, so that's what you should be focusing on. Basically, your stereotypical polygons that you've seen whenever you've probably learned about them. Most of the time they look like that, especially the regular ones. So polygons have names based on their sides. So for example, 3-sided one, we have a triangle. That one is pretty well known to you by now. 4-sided polygon, we have our quadrilaterals. And then we have the ones that end in gon. So we have pentagon. We have hexagon, heptagon, octagon, nonagon, and then decagon. So, those are those names of those polygons. Based on the number of sides, it would be good to know them. And then once you get past there, typically we start using the number, then a dash, then gon. Like if there were a 43-sided shape, we would call it a 43-gon. And if we don't know the number of sides yet, we usually call it an n-gon. So those are two other words to know. All right, next side of the page. We're going to skip these examples for now. You're going to have a different video for examples, so let's go straight to the exterior angles theorem. So when we have a shape, and this even works with triangles, and it doesn't have to be a regular shape, it can be any shape, we can extend the sides, and as long as we do it the same way for each side, this was the extension of this side, that was the extension of that side, we form these angles here. And those are called exterior angles. Well, what I'm here to tell you with this theorem is that the sum of exterior angles is always (360°). And that is going to be, that's going to play into some of the problems that you see coming up as well. So, just knowing that the sum of those angles on the outside always add up to 360° is going to be something that you want to remember for this chapter. So, all we have left on the sheet is examples. As I told you, I'm not going to go through those in this video. You'll want the properties of quadrilateral sheet for the examples that I'll be going through. It's available. So, good luck with those. And if you think you're ready for the assignment, go for that. If you want to see the example video, look for that on my channel. Talk to you later.